Well, for alpha, the infectives will be faster. So we're going to have a. I guess you could watch me as I do this. Farhad, you can add an experiment, right? Fine.
Yeah, but I want to know why I can't copy it and paste it when
Right.
I want to paste it.
I will do this. Yeah. I just want to make sure it wasn't blocky. Okay. Very fast infectives. This will be an alpha of 10. What do you think's going to happen then? Can anyone say? Will people get infected faster or slower than the baseline with alpha equal 1? Yeah, it's very rapid, very rapid. So, ladies and gentlemen, does the speed of you might have, I should have actually started the class with this question. Does the speed at which someone is moving once they're infective end up affecting things? And someone could reasonably argue, well, it shouldn't, because after all, they have to be somewhere. Why does it matter if they're just moving them around randomly? Why does it matter where they are? They're at an arbitrary position wherever they are. Why does it matter where they are? They could just stay still. Other people will come to them. Why does it matter that the people are moving? Their relative position is random anyway, so why does it matter that they're moving? Well, it turns out it does matter because they can touch more people if they're moving quickly. They can sort of zap by people and disturb a larger number of people. And I think comparing the regular simulation, a simulation where there's a large population and just a sort of normal movement of these people. I'll play this at full tilt here, and you could see it rising, and it's diffusing through the population there. That spreads quickly. Certainly, a situation where there's no infective movement at all. Here, we have a situation where once someone's infected, they don't move, and what you see is there's some aggregation going on, but it's really not spreading to a lot of other areas of the space, right? I mean, how is it going to spread? As soon as someone's infective, they stop. So there's no one, they're not going to bring it over here. It depends on people coming over to the spot, and I'll get to Bahare here. And the final one where we have very fast infectives, where we have this situation where the infectives, end up just spreading very quickly over to the population. It becomes dramatically apparent. Intuitions, and it helps put aside uncertain intuitions, that in fact the speed can have a very material impact on the spread of infection through the population, even though it might not seem that way. It took a number of Gedanken experiments for me to convince myself, yes, it does, but I'm surprised at how dramatic it is. So Bahare, yes. Well, I think it's because they stay infected for some period of time, and during that period of time, if they're moving quickly, they're gonna be encountering more people along the way.
The rate of infecting people is big. That's a big number. 0.2 or 0.2.
Is what? Is the
rate of infecting under
oh yeah,
space.
right. This sort of rate, it's 5 times per time unit. Yeah. So yes.
So if at each of these
Correct.
times, each of these even if the agent
I see what you're saying.
Important.
Yeah. A very good point. So you're saying, very good point. Okay, I think what you're saying is, look, what we're seeing here could be an artifact of, it could be a sort of just an, it's not, it may not be something really deep, in the sense that what we may be seeing may be a reflection, particularly for this case where we have agents not moving at all. You know, what we may be seeing, the sort of limited spread here, may in fact be a reflection of the fact that, you know, these agents who are infective aren't, you know, infecting all these nearby susceptibles who are just barely going by. After all, there's even a green one underneath them there, if you look. Well, it was. But you know, look at these. Some susceptibles are going over them, not getting affected, because the nearest one is like the red one right under them. And so this may be, it may be that sort of the vagaries of how we implemented, look at that, how we implemented that rule are affecting this in a big way. That it takes a really unlucky, look at that, this guy, oh, okay. It takes a really unlucky hit for this thing to, well, that's an exaggeration, but there's a lot of glancing hits which don't infect actually anyone, like that guy who just went through right there. He got it. Okay. So I think Bahare is saying, well, wait a minute. Why don't we examine loosening that restriction? So instead of saying it has to be the nearest agent, why don't we infect all nearby agents within a certain radius or something like that, right? At least one susceptible agent. So I like that idea. So what I propose to you is a challenge. I propose a challenge for next time, being I would like you to tell me, and I'd actually like to implement a strategy for infecting all the people near you who lie within a certain radius, okay? Or at least you'll send messages to all of them that lie within a certain radius, okay? Everyone who lies within a certain radius, you'll send a message. If that message is received by a recovered, will it make a difference? No. It'll just ignore it. If it's received by an infectious, will it make a difference? No. It will only make a difference if it's received by a susceptible. So I'd like you to tell me, how could I modify this model so that that person, when they're infectious, they send messages to all the people nearby within a certain distance? That is what I'd like the riddle for you to work on.
If you change the rate to 1, it's almost similar, yeah? Infection rates will be 1. Yeah.
Okay.
We have a distance for connection between our agent, because our network is distance-based. So it's exactly.
Oh, the distance. Well, actually, there's no network that's distance-based now, though. We're only, actually, Farhad, you didn't see this from last time, but here we actually get the nearest agent to us directly. We have code. When you're in this state, you're going to expose someone. You expose only the nearest agent, and then you check if that person is within a certain distance. Then you infect them. What Bahare is saying is, you know, let's infect, say, people with a different role. But I want to say, Farhad, your idea of using a distance-based network is one way to do it. You could connect with all people who are within a certain distance and expose them. And that will be one way of doing this. So you've already worked on the riddle and made progress on the riddle. So that will be one approach we could take to the riddle. And perhaps the one we'll adopt next time. We'll see. Okay? So I want you to think about that. How many people here believe that the velocity, let's suppose we fix this point that Bahare has made, which is a substantive point. One thing you got to be very careful about with these models is you don't want just the accident of how you happen to implement it, ladies and gentlemen, to affect the results. Sometimes weird things that you just thought as it were convenience, the fact you have a limited size space, maybe that ends up affecting in a big way the results in a way that wouldn't be really realistic in a real world situation. So Bahare's point is a deep one, and I'd like to pose it as a challenge to the group. Well, I can send it via Instagram if you want. That we end up solving this and seeing if this phenomenon persists if we infect all people within a certain distance. So Farhad has given a clue to solve the riddle. There's other approaches to it too. I would like you folks to think about this and perhaps even to return with some of your models addressing this challenge. Okay? Okay, very good.